Hi there. So in this tutorial, we're going to learn how to use for loops and iteration and include a really special piece of electronics, NeoPixels. So this is a strip of NeoPixels. This is a really tiny, cheap strip. These are also known as, I'm going to pull up a little tab here, WS2812B addressable RGB LED strips. Many people find these online and they're really popular in things like TikTok videos. There's two versions you can get. There's a 5-volt version and a 12-volt version, and you need the 5-volt version to work with microbits. You should also look for the kind that have just 3 pins. So that's what these have here. So WS2812B RGB LED strips, and they're fully programmable. They're really fun. They're really easy to use. So what we do is we go into our Python editor, and before we do any code editing, let me just show you how we attach to these. So when you can cut these strips, and when you cut them, you have to make sure you cut them in the middle of the little copper tabs. So I don't know how easy that is to see, but there's copper tabs that look like little ovals in between the LEDs, and you want to make sure you cut those in half. When you solder wires onto them, you're going to look for the little arrow or the triangle that's like pointing in a certain direction. So I have that arrow kind of pointing up, and you attach the wires to the side that's kind of pointing away from the arrow. So you want the arrow to be basically pointing away from your wires. I've soldered some wires onto a strip of 5 LEDs here, and I've made sure that my black wire is on ground, my yellow wire is on DIN, and my red wire is on plus 5 volts. So I try to keep them color-coded so I remember which one is which. And then after I soldered the wires on, I did a little hot glue and electrical tape just to make a little sturdier connection right there. So that should hold them on there pretty good. I'm not going to try to wiggle them or jiggle them around too much, but that should hold the wires in place. So next, to attach them to the microbit, you're going to do 3 alligator clips, and I strongly recommend you color code your alligator clips the same as your wires on your NeoPixels. So black, I've got going to ground, okay? Red goes to 3.3 volts. Yellow goes to pin 0. And these are going to line up with the matching wires on your NeoPixel strip. Ground, data, and plus 5 volts. So yellow to yellow, black to black, red to red. Make sense? And then you just clip them on and your NeoPixels are ready to be programmed. So yellow and black and red. And do try not to let the metal parts of the alligator clips come into contact with each other. So if you need to kind of spread those alligator clips apart a little bit and set them on a desk so they don't touch, make sure you do that. Don't let them touch each other. You don't want to make a short circuit. So there's my NeoPixels. Next, we're ready to code them. I'm just going to, sorry, I need to set these in a place where they're not going to be pulled off the table. There we go. Okay, that's what this interface is for. So before you can code anything, there's a library you have to import. It's easy. You just do import NeoPixel. Okay, and I believe it's all lowercase, but if you forget, go to the Python documentation for microbit, and you're going to look in the left. There's a menu option that says NeoPixel. Click on that, and you get to the help file on NeoPixels, and you can see right there at the beginning, import NeoPixel, all lowercase. And if you scroll down, you can see more how to code them. Now, when you code NeoPixels, you have 3 data values you need to give it to set the color of the pixels. And look at that animation. Isn't that pretty? The 3 values are the value of the red, the value of the green, and the value of the blue. And they go in that order, red, green, blue. It's very much recommended for NeoPixels running on the microbit. You don't choose numbers higher than, say, 64. So what you can do to pick a nice color is if you just do a Google search for color picker, you'll get this color picker in the top. And if you take the little color selector and move it kind of close to the bottom of your hue and all the way to the right, that'll give you the most vibrant colors. So near the bottom, all the way to the right, you kind of want to pick the color values where when you look at RGB, you don't see anything over 64. 64 is plenty high enough to give you beautiful, vibrant colors, and you're not going to be drawing so much current that you'll burn your batteries out. So once you've got the brightness selected, just move your color shade over, and you can see over in this window roughly what the color will look like, but it'll look much brighter on the NeoPixels. Trust me on that. So there's green, red. That doesn't look very yellow, but trust me, it's going to be yellow. blue, purple, and so on, okay? So you can use that to choose colors. I'll start off just by programming basic red, green, and blue. So I'm going to get rid of this code inside while true. Before while true, you have your startup code, and here's where you need to initialize your NeoPixels. So we'll make a variable called np equals NeoPixel dot, then you put NeoPixel with a capital N, capital P, and parentheses, you put the pin number and then a comma and then how many LEDs you have. Mine are on pin 0 and I have 5 lights on my strand. Okay? Next, inside the loop, you can start setting colors for your NeoPixels. So let's say at first glance, I just want to set the first light to red, second light to green, third light to blue. So NP sub 0, notice that every time you have a list, like your NP is a list of NeoPixels, individual NeoPixels, all lists start from 0. So this first NeoPixel, I'm trying to yank this over here so you can see, the first NeoPixel is NeoPixel 0, 1, 2, 3, 4. There is no 5. It just goes 0, 1, 2, 3, 4. Okay? So we'll set NeoPixels sub 0 with the little square brackets equal to, and then we just do a set of parentheses and we'll put our RGB values. 64, 0, 0. All red, no green, no blue. NeoPixel sub 1 will be equal to, parentheses, 0, 64, 0. NeoPixel sub 2 will be equal to, parentheses, there we go, 0, 0, 64. All, no red, no green, all blue. So we'll have 3 lights in a row, 1 red, 1 green, 1 blue. And then just for grins, since I have 5 lights, let's add a couple of the secondary colors. The secondary colors are made by mixing 2 of the primary colors and only 2 of the primary colors on their full brightness. So NeoPixel sub 3 could be, for example, yellow, which is 64 for the red, 64 for the green, and no blue. And then let's make our last NeoPixel magenta. So NeoPixel sub 4 is equal to all red, no green, 64 blue. Notice in some of these parentheses I have no spaces between the numbers and commas. In the second set I do have spaces between the numbers and commas. I really should be consistent, but there isn't any harm in extra white space in this situation. You just want to be careful of white space in the tabs. Now the last thing you need to add is your NeoPixels won't display unless you use the command show. So you need to do np.show to make all those colors show up on your NeoPixels. Okay? And if you have any questions about it, just go back to the documentation. If I scroll down, I can see that right here, np.show. Okay? So that's it for the basics of NeoPixels. Let's download this program, and I'm going to name it NeoPixel 1. Download. And my program's here. Drag it onto the microbit. It's uploading. And then hopefully we'll see some magic. Look at that. We have red, green, blue, yellow, and magenta. And see, even with the color values turned down to 64, the colors are beautiful and vibrant and really quite bright. You can power up to 8 NeoPixels with the microbit battery, but you really shouldn't power any more than 8 with the AA batteries that come with the microbit. If you're trying to do more than that, then you need to clip the red and black leads to a stronger power source. So that's the basics. Then just for fun, you can use for loops to kind of like iterate through the pixels on a NeoPixel strand. So let's say I make a list of colors. We've shown before how we can make a list of numbers. A list of colors works really similarly. So I'll make color list, which is a variable, and then in square brackets I can put a list of RGB values in parentheses. So my first color list will be this one. My second item in the list will be the green. See how that works? I've got the parentheses with my RGB values, then a comma, and then another complete set of parentheses with RGB values, then another comma, and then so on. Okay, We'll keep going. I'm going to go on to the secondary colors. I accidentally hit Control V instead of Control C. I got this. Okay, and then our last secondary color that we have in this program. The one secondary color we didn't include yet is cyan, so let's go ahead and add it for completeness. That's 0 red, 64 green, 64 blue. Okay, so from here, what we'll do is we'll pick a random color from that list, and we'll set all the NeoPixels to that color, and then we'll just repeat that over and over again and let it show a random rainbow color on the whole strand every time. To use random choices, we need to import another library, so we're going to say import random. Okay? And then one of the cool things that random can do is it can pick a random item from a list. So we can say, for example, C equals random.choice color list. Okay, and then pardon me. Once we've selected a random color from that list, then we'll apply that random color to the whole string of NeoPixels using a for loop. So we can say for I in, let's just do, so we're going to go to every pixel in the NeoPixel strand, and there's 5 of them, 0, 1, 2, 3, 4. So we could either do range 0, 5, which would give us the numbers 0, 1, 2, 3, 4. Or we could do a square bracket and list 1, 2, 3, 0, 1, 2, 3, 4 in there. I'll do the range 0 to 5. So for every one of those numbers in the range 0 to 5, I realized I almost forgot a very important thing, the colon after range 0 to 5. There you go. And then next we'll say NP sub I equals C. So C is just a random color from the list, and a color is this RGB values inside parentheses. So it picked one of those and set it equal to C. So now C is a random element from this list, and it's a complete color. So we set NeoPixel I to that color. And then we'll do a sleep, let's say 300. So it'll like do a little delay in between each NeoPixel. And it's really important to do np.show. And I decided to put it before the sleep. So we'll set the NeoPixel to that color, show it on the NeoPixel, do a little delay, and then go to the next NeoPixel in the list. Once all NeoPixels have been changed to the color that we just chose, we'll pick a new color and then cascade that down the list. So we should see this really beautiful animation of like one color after another cascading down the NeoPixels. And that's it. So I'll give it a new name, NeoPixel Marquee. Just made that up, and then we'll go ahead and download it. Okay, I'll go over to my File Explorer, and we'll pick up NeoPixel Marquee.hex and drag it onto the microbit, and it's flashing. Wait for it. Okay, and there you can see my NeoPixels are changing colors. They've turned magenta, and then all red, and then all yellow, and then all cyan, and then all blue, and then all green. So they're just picking a random color and cascading it down the strand every single time, and you have these really gorgeous animations. I'm sure you can think of a gazillion fun things to do with NeoPixels. They're very engaging, a lot of fun to add to any electronics project, and maybe you can think of a good application for your Global Goals project. Good luck.